Hey, AGS1, here is one more example if you would like some extra explanation and some extra help on how to find different features of a function. So we're going to be going through all of these different features using the graph that you see here. The first question that comes up is whether the graph is a function or not. And we talked about in class what we called a vertical line test. And what I'm going to do here is just draw a whole bunch of vertical lines on my graph. And I'm going to come back to that one. And the idea behind a function is that every one input has exactly one output. So I'm looking for essentially that for that vertical line to pass through the graph just one time anywhere I draw that vertical line. And the part that I'm really going to zoom in on here, literally, is this one. Look at this right here. This is the only place where I'm looking to see possibly that there's 2 points of intersection on that graph. However, we've also mentioned before that a closed dot means that that point is included, and an open dot means that that point is not included. So there's actually, although it looks like I'm kind of touching the graph there twice, there's only one point at that exact location. So that means for us, get rid of those guidelines there, that means for us that we do in fact have a function. So the yes or no question to the function is yes, it is a function. And so the next one we're going to look at is the domain. And the domain is any of our x values that go into the function. So essentially, I like to think of it sometimes as how wide the function is. So when I'm looking along the x-axis here, okay, my x values begin here and they end there for my function. And so it looks like on an interval that's going between 0 and 21. So I'm going to write that in interval notation here up by my domain. And so that would be including the point 0 all the way up to the point 21 and including that point as well. So there's our domain. Okay. Next up is the range, and the range is all of our y values. So essentially, I think of it sometimes as how tall. Okay, how tall is that graph from the very minimum point to the maximum point? And it looks like my graph, if I'm going along the y-axis, right, minimum point's down here. We'll get to that one in a bit. And the maximum point is up here as well, and we'll get to that one in a bit. So it looks like it does stretch all the way down here. So, -2.5, not quite at -3. So I'll say -2.5. And it goes all the way up to 10 and includes 10. So I'm going to make sure that for my brackets, when I'm doing interval notation, that I get the square brackets that include the number there. So that was my range. Okay, let's go for the x-intercept is next. And the x-intercept is where that graph intersects the x-axis. So I'm going to run along the x-axis again. There's a couple, aren't there? There's one right here. Let's see where I put that point there in yellow. And then there's another point right here. And that's okay. There could be a bunch of them. I'm going to go back and make that a little bit darker there. There's an x-intercept and there is an x-intercept. It's where that graph touches the x-axis. And it looks like that point is just shy of 15, right? How about we'll estimate that. I'm not quite sure. How about 14.8? 0. So that's going to be an x-intercept. And then this one, that one looks like it's more exact there. That's the point 21, 0. So those are my two x-intercepts, and I'll write those here as points. So that one is 14.80 and 21, 0. Okay, let's go to our y-intercepts next. Okay, my y-intercept, if I look along the y-axis now, is where that graph hits the y-axis. And it looks like it's got one point right there, up at, let's see, that'll be the point 0, 10. And just a note as we're going through these, right, that the x-intercepts will always have a y value of 0, and then the y-intercepts have an x value of 0 since you're running along the y-axis. Just good to note there. So that's the point 0, 10. All right, so let's go now to our minimum and our maximum. Okay, our minimum point is the lowest point on the graph. It's the bottom here. So we mentioned that point before. We needed it for the range. Okay, but now that's the lowest point I see, and the highest point I see also happens to be where that y-intercept was. So here's our minimum. That's a new point for us. So this one is, let's see, again, approximately 15, 16, 17, 18, 19 and a half, negative 1, 2. So 19 and a half, negative 2 and a half for our minimum. Okay, so I will write that there, and then our maximum is the same as our y-intercept. So let's go ahead and add those in, minimum and maximum. Minimum is 19.5, negative 2.5, and then the maximum is the 0.0, 10. Okay, 2 more to go. We're going to look at an increasing interval and decreasing interval. Okay, let's look first at our increasing interval. So my increasing interval, this is like that pool problem when the pool was filling up and we talked about it rising and having a positive slope. So even though this graph is curved, we could still find points when we when we read that graph from left to right, we can still find intervals where that graph is increasing. So it looks like for increasing, I am going here and up to right there. See that? So that little upward slope there is an increasing interval. And if I correspond that down to my x-axis, that's how I'm going to write my interval, is the span or the interval along the x-axis. And it looks like that graph then is increasing between the intervals of 6 and 8. Okay, so it's increasing from 6 to 8. So hold that thought because I see one more increasing interval. Okay, from here we're going down, 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 down. But right after you hit that minimum, that graph curves back up again, doesn't it? Okay, so there's one more interval there where that graph is increasing. And if I look along the x-axis, it would be right here from that span. So these are 2 intervals. So I'm going to write 2 different interval notations, but connect them with a U. We call that a union. So let's see. Now this interval, notice too that it starts with an open circle. So I'm not going to include my 6, but it's everything from 6 to 8, including 8. Okay, so that was this little interval down here from 6 to 8. And then my second one, so I'm going to make another one, so that little union sign there. And that one looks like it is going from, you know what? Now that I'm counting this again, I'm realizing I'm going to go back. I don't think that's 19.5. I think that's 18.5. So I'm going to make that change to the minimum here while I'm thinking about it. Sometimes it's totally fine to go back and adjust your points. Sometimes hard to get that distinction when you're making a video. Okay, so here's 15, 16, 17, 18.5. So that next interval starts at 18.5, and we'll include that. So from 18.5, and it's going up to 21, and then we'll close that interval there. Okay, one last one, and that's the decreasing interval. So last color here, we'll do pink. All right, so our interval is decreasing, or a function, I should say, is decreasing. Okay. Looks like we're starting here and we're going down the slope until we stop here. So we've got a decreasing interval from, let's see, from 0 up to 6. Okay, so that's one decreasing interval. In fact, we could label these. Here was a minus. I'll go back to the purple real quick. I just like to mark up my graphs. It helps me go back, especially when it's color coded. I can see what's happening there. Okay, and then the other decreasing interval is, looks like we're gonna start at 8 and we're gonna go, this is like you were sliding down, right? This is the downward slope of the roller coaster until it twists back up again. So this interval here is from 8, and then it'll go all the way up to that 18.5 where we started to increase again. Okay, so there's two intervals that we need to write. Okay, the first one went from 0. I'm going to erase the word max there because it's kind of in the way. So my first one started and included 0 and then went up to 6. Now I didn't include 6 in that increasing interval, so I'm going to include it on this one. You just don't want to double count it in an interval, so just, you'll get the hang of that. We're just practicing here. Okay, and then my second one goes from 8. Now I'm waiting on my bracket here because I'm looking to see what I did before. Okay, so I included, see up here, I included 8 on that interval. So I'm not going to include it on this one just because we don't want to count 8 twice, then we don't have a function. So we're going from 8 all the way up to that 18.5. And just like the other one, I included 18.5 in that first increasing interval. So I'm not going to include it on that one. And I think that should count for everything. When I look at the span of the decreasing and the increasing intervals, I'm going from 0 to 6 and 6 to 8, 8 to, and I'm just kind of checking that I have the whole span there. It looks pretty good. So that is one more example of how to write and use interval notation, our coordinate points, when we're talking about features of a function.